ಪ್ರತಿ ಕ್ಲಾಸಿಗೂ ಇದು ಸರ್ ಹಾಗೆ ಸರಿ. Good afternoon to all students of B.Sc third semester. So, as per the third semester syllabus as concerned, especially physics, there is geometrical optics, then aberrations, and dielectrics, current electricity, transient of circuits, electrical measurements and instruments. These are the topics of the physics for B.Sc third semester. So as per my syllabus is concerned, the transient of circuits. Then I am going to deal another topic, electrical instruments and measurements. So before going to start this chapter, transient of circuits. So transient of circuit deals the charging of the capacitor through high resistance, discharging of the capacitor through high resistance, growth of a current through induction coil, decay of a current through induction coil through high resistance. So before that, you'll have to know about some circuit elements. What are the circuit elements? Circuit elements are two types. Active elements and passive elements. What are the active elements? The elements are the devices in the circuit which gives energy to the circuit. For example, source of EMF, diode, transistor, IC, all belongs to active elements. The source of battery, source of EMF, Semiconductor devices like diode, transistor, FET, IC, integrated chips. So all these are considered as active elements. And passive elements are three types. That is resistance, capacitor, capacitors, and inductors or induction coils. So it is R, C, L. Namely, it is RLC circuit. That is a resistance, capacitor, and inductance are the passive elements. Means they generate heat energy, mechanical energy, and electric energy like this. What they generate when they are in the circuit, they are considered as a passive elements. So generation of the energy in the circuit, they are called as active elements. So that circuit elements are two types, that is active elements and passive elements. Example for the active elements are source of EMF, diode, transistor, FET, IC. Means all semiconductor devices are belongs to active elements. Then passive elements are concerned resistance, capacitance, and inductors. Just they are the three components very important in RLC, etc. In any kind of electrical circuit or electronic circuits. See, any kind of electric circuit or any kind of electronic circuit, there must be a resistance, capacitor, and inductance. Without all the three, there is no the electronic or electrical circuits. That's why they are the fundamental or basic elements which are present in electric circuits or electronic circuits. Okay, what are the passive elements? They are the resistance, capacitors, and inductors. Let us have some definitions connection with all the passive elements, because without knowing the definition of passive elements like resistance, capacitors, and inductance, they are not able to understand the transient circuits now. So, what is the resistance? As per the Ohm's law, according to Ohm's law, R is directly proportional to B. I is the current through the conductor, E is directly proportional to the potential difference maintained across the ends of the conductor. Whenever you increase the voltage across the conductor, there is an increase in current. When the voltage decreases, current also decreases. That's why the equation you can write, that is V equal to IR. R is the resistance of a conductor. That's why R is equal to V by I. So resistance means, here the definition for the resistance is the opposition to the flow of a current. Or resistance or resistance of a conductor is the opposition to the flow of a current. If there is more opposition, there is a less current. There is a less opposition, there is a more current in the circuit. That's why the resistance of a conductor is measured by the ratio of voltage to the current. What voltage is given across the devices, maybe resistance or inductance or capacitor. The voltage given, for that voltage, what current flows through the conductor, the ratio of the voltage to the current itself is called as a resistance. That's why resistance is the potential difference divided by current. Okay, potential difference to the current, it is measured in ohm, SI unit of the resistance. SI unit of resistance is 1 ohm. How you define 1 ohm of resistance? If 1 volt of potential difference is maintained across the conductor to set the current of 1 ampere of current. If 1 ampere of current flows for a potential difference of 1 volt, then the resistance of a conductor is said to be 1 ohm it is. Okay. Now, the resistance depends on what factors? Usually, the resistance depends on resistance of a conductor, depends on four factors, that is length, area of cross section, nature of the material, and the temperature. That you can use the word length. Okay. One is the length, another is the area of cross section. Whenever there is a change in the length, there is a change in the resistance, and the area of cross section of the material of a conductor varies, resistance varies. If the nature changes, nature means copper, aluminum, iron, cobalt, nickel, all these are the conductors. If the nature is different, resistance is different. Then the resistance also varies with the temperature. Okay. Therefore, here L is the length, A is the area of cross section, N is the nature of the material, and D is the temperature. So, how the resistance varies with the length and area of cross section? See, very important. Resistance is directly proportional to the length, inversely as area of cross section. Okay. Then itself is considered as that is R is equal to rho L by A. What is rho? Rho itself is the resistivity of a conductor or specific resistance. Resistivity is equal to rho equal to RA divided by L. If area of cross section is 1 meter square, L is equal to 1 meter, then rho is equal to R itself is the definition for the resistance or resistivity or specific resistance. Resistivity is equal to the resistance of a conductor of unit length and unit area of cross section. Very simple definition. As rho is equal to RA by L, okay? When A is 1 meter square, unit meter square, L is equal to 1 meter, which is unit meter, then automatically rho is equal to R. That's why specific resistance is equal to the resistance of a conductor of unit length and unit area of cross section. And what is the unit of the specific resistance? See, resistance measured in ohm, area of cross section measured in meter square, length measured in meter. So meter get cancelled. So the specific resistance measured in ohm meters. Okay, this specific resistance used to measure the conductivity. Usually, the conductivity of the material, that is sigma, is always equal to 1 by rho. And the conductance is reciprocal of the resistance. The conductance, that is C, is equal to 1 by R. The conductance is the reciprocal of the resistance, and resistivity, conductivity is the reciprocal of the resistance. Okay, this is the definition for the resistance. Next, the factor is the induction factor. Here, the three factors are there: R, L, C. Okay, these are the building blocks of electronic or electrical circuits, like Brahma, Maheshwara. Okay, good. That is R, L, C. R is the resistance, L with the induction coil, C with the capacity or capacitor. Whatever electronic circuit or electrical circuit, it must have certain component R, L, C. That's why these are called as passive elements. Okay, now you know the definition of resistance. Next, self-induction of a coil. Self-induction of a coil is represented as L. What is self-induction? Suppose there is a coil here. If it is connected to the battery or EMF, when the circuit is switched on, current is growing in the circuit. As current is growing means increasing in the circuit. As per the magnetic effect of current, whenever current flows through the conductor or coil, the magnetic field is produced. Okay. So the magnetic flux is released. What kind of magnetic flux? That is magnetic field itself is a magnetic flux density, means the number of lines of forces per unit. That magnetic flux density increase or it may decreases depends on the strength of the current or change of the current. Whenever current increases, magnetic flux linked with the coil increases. When the current decreases, magnetic flux linked to the circuit decreases. So, when there epsilon equal to d pi by dt, pi is the magnetic flux. That magnetic flux is equal to L into I. L is the coefficient of self-induction of coil. I be the current through the coil. Now epsilon is equal to, that is minus d by dt of pi itself is Li. So it is minus L di by dt. Here L itself is called as a coefficient of self-induction. See here, the expression itself state the definition for coefficient of self-induction. See, the EMF is exist in the circuit, and during the change of current in the circuit, di by dt must be there. If there is no di by dt, only the constant current flows, EMF is zero. What EMF it is? Induced EMF or instantaneous EMF. Why it is called instantaneous EMF? That is EMF induced in the coil or generated in the coil during the instant of change of current. There must be change of current. Either current may be increased in the circuit or current may be decreased in the circuit. There is a change of current, then only the EMF in the circuit is exist. That's why coefficient of self-induction can be defined as if di by dt is equal to 1 ampere per second. See, di is the change of current measured in ampere. Dt is the time. What change of current is that? The di change of current during an interval of time dt, that is 1 ampere per second. As di by dt is equal to 1 ampere per second, substitute in this equation, what happens here? Epsilon is equal to minus L. Okay? That's why the definition itself is L is a coefficient of self-induction, is numerically equal to the EMF induced in the coil during the change of current at the rate of 1 ampere per second. So all the definitions can be stated with the help of the mathematical expression or the connected expression. See, epsilon equal to minus L by di by dt is that. As and when di by dt is equal to 1 ampere per second. What is the expression here? Epsilon equal to minus L. Simply, you can state the definition of coefficient of self-induction. Self-induction is equal to the EMF induced in the coil during the change of current at the rate of 1 ampere per second. Okay. Then one may ask question here, what is the statement of minus means negative sign represents what? See here, whenever current increases in the coil, the EMF induced in the coil which opposes the change of current in the circuit, means opposes the growth of current. Okay? When the current is gradually increased in the circuit due to flow of current only, the magnetic flux is released inside the coil. That magnetic flux, change of magnetic flux, causes for generation of EMF, but that EMF opposes the rise of current. That's why it is called that is reverse EMF. It is. What is reverse EMF? What EMF is generated in a coil during the rise of current or growth of current in the coil. Okay? Now, here, what EMF is induced in the coil opposes the change of current, means rise of current. Opposition represents a negative sign here. Okay? Suppose current is switched off, means if the press key is released, automatic current starts to decrease in the coil from maximum to 0. When current decreases to the minimum value, at that time magnetic flux linked with the coil also decreases, means there is change of magnetic flux, and when there is a change of magnetic flux due to change of current, there is a EMF induced in the coil again. That EMF again opposes the fall of current. See, during the rise of current or rise of current takes place during switch on. Fall of current takes place during switch off. Okay? Either switch on the circuit or off the circuit, there is an opposition offered by the instantaneous EMF. During the rise of current, EMF is used to oppose the rise of current. When switch off the circuit, there is again EMF is induced. That EMF opposes the fall of current. Okay. Totally, that EMF nature is to oppose the change of current. That's why either switch on the circuit, switch off the circuit, there is an opposition offered by the induced EMF. That's why it's considered as a negative sign. It is applicable for growth of current as well as a decay of current. Now, the practical unit of L is Henry. L is equal to L measured in Henry. How you define 1 Henry of self-induction of current? Say epsilon equal to minus L. Okay. When it become 1, if epsilon equal to 1 volt, okay, di by dt equal to 1 ampere per second, and here see the equation, epsilon equal to minus L di by dt, as di by dt equal to 1 ampere per second, E equal to 1 volt, then L is equal to 1 Henry. So this is the definition for SI unit of self-induction. SI unit of self-induction of a coil, nothing but that is 1 Henry of a coil. When the coil offer 1 Henry of quotient of self-induction. Okay. Statement is that here simple. Epsilon equal to minus L di by dt. As epsilon is 1 volt, di by dt is 1 ampere per second, L should be 1 ampere. So you can define it. When current changes at a rate of 1 ampere per second in the coil, then it generates induced EMF 1 volt. Okay. Quotient of self-induction is said to be 1 Henry when current in a coil changes at a rate of 1 ampere per second for a generation of induced EMF of 1 volt. That is said to be L equal to 1 Henry. Yeah? This is the definition for quotient of self-induction. So self-induction nothing but the generation of EMF during the change of current. Just important. Epsilon equal to L di by dt. EMF is generated during the only change of current. If there is no change of current, if constant current flows in the circuit, there is no EMF induced in the coil. So, generation of EMF in the coil during the only change of current, andre current increase ಆಗ್ತಾ ಇರಬೇಕು ಅಥವಾ current decrease ಆಗ್ತಾ ಇರಬೇಕು. If constant current flows in the coil, there is no EMF induced in the coil. That's why the simple statement for this epsilon equal to minus L di by dt. Di by dt must be there. Then only the EMF is there. Di by dt is change of current. Change of current, it may be increase of current or decrease of current. Whenever current increase in the circuit or decrease in the circuit contained in the coil, then there is an EMF in the coil. Okay. This is the definition for the coefficient of self-conduction. Okay. The third element, circuit element, is the capacitor. What is that? Capacitor C. So, capacity of the capacitor nothing but usually Q is directly proportional to V. Suppose there is a conductor. What is the capacity of the conductor? Capacity of the conductor can be measured by certain amount of charge given to the conductor. The quantity of charge acquired by the conductor proportional to the voltage of the conductor means potential of the conductor. Potential of the conductor increased as the charge given to the conductor is increased. For example, if there is a water tank, if there is a continuous flow of water by the tap, then there is an increase in the level of the tank. Okay. The capacity of the tank depends on what? The quantity of water flows with respect to the tank. But the capacity of this tank depends upon the volume of the tank. If the volume of the tank is very small, within a short time that may fill. If the capacity of the tank is more, then it can store a maximum volume of water. That is the capacity is to store the quantity of water in the tank. Like that, here the capacity of the conductor depends on how much quantity of charge can able to acquire by the conductor. That is Q proportional to V. That's why for every proportionality there is a proportionality constant, that is Q equal to CV. C itself is called capacity of the capacitor or capacity of the conductor. That C is always measured by Q by V. This is a statement, very important terms. The C equal to Q by V means capacity of the conductor or capacity of the capacitor measured by the ratio of the charge acquired to the potential difference maintained across the capacitor. Okay. Usually, capacity of the capacitor measured in farad. This is the SI unit of capacity of the capacitor. Then, how you define C equal to 1 farad? That is C equal to 1 farad when if Q equal to 1 coulomb, V is equal to 1 volt. Simple, C equal to 1 farad. So, SI unit of capacity of the capacitor can be defined as if the charge stored or acquired by the capacitor is 1 coulomb. To develop a potential difference between the place of the capacitor is 1 volt, then capacitor of the capacitor is 1 farad. Usually, farad is a large unit. That's why sometimes the capacity of the capacitor measured in millifarad. that is MF, microfarad, mu F, milli means 10 raised to minus 3 farad, micro is 10 raised to minus 6 farad, nano farad is equal to NC, that is 10 raised to minus 9 farad, picofarad, that is PF, NF, PF, pico is 10 raised to minus 12 farads. Usually capacity of the capacitor measured in millifarad, microfarad, nanofarad and picofarad. 1 millifarad is 10 raised to minus 3 farad, 1 microfarad is 10 raised to minus 6 farad, now 1 nanofarad is 10 raised to minus 9 farad, picofarad is 10 raised to minus 12 farad. Okay. Now, usually capacity of the capacitor nothing but usually it consists of two parallel plates or the cylindrical plates or the spherical plates. If it consists of parallel plates, it is called parallel plate capacitor. If it consists of two cylindrical cylinders placed coaxially, then it is called cylindrical capacitor. If it consists of two spherical cells, that is called spherical capacitor. Okay. Now, it is a capacitor. One is acquire a positive charge and another acquire a negative charge and separated by small distance, and that separation between the plates is usually filled with a dielectric elements. Dielectric means insulating materials. Usually in the construction of capacitor, mica, paraffin and some dielectric material like papers, wax papers are used as dielectric. So as a dielectric material have certain dielectric constant, the dielectric constant increases, capacity of the capacitor increases. Okay. What is a capacitor? Capacitor is an electrical device used to store electrical charge. For that, the quantity of charge acquired by the capacitor corresponding, there is a voltage across the capacitor. By knowing the charge stored in the capacitor and what voltage is developed across capacitor, then you can measure the capacity of the capacitor as Q by P. That is C equal to Q by P. That's why here the three important relations are there to study the transient circuits. That is V equal to IR for resistance, epsilon equal to minus L di by dt for coefficient of self-induction of coil, and for capacitor C is equal to Q by V. These three relations are very important because for every electrical circuit there is a inductance, capacitor, resistance. Whenever you can going to find the current in the circuit or voltage across the circuit or charge in the capacitor or capacity of the capacitor or what is the EMF induced in the coil when coil present in the circuit, all these to determine all the three equations are very important. Ohm's law is V equal to IR, epsilon equal to minus L di by dt, C equal to Q by V. As the three elements are very important in the electronic and electrical circuit, corresponding their equations are also very important to study the RLC circuit. Okay. Now, to start the transient circuit, first subtopic is the charging of a capacitor through high resistance. Charging of a capacitor through a resistance. That's why it is called charging of RC circuits. Means the circuit containing resistance and capacitor. See here, there is a resistance in the circuit. Usually, the symbolic representation of resistance is R. Here, there is a capacitor. The value of the capacitor is C. Okay. To charge the capacitor, there must be a source of electric current. There is a battery. Okay. And here it is connected to the MOS key. MOS key used to charging and discharging the capacitor. See, as per the circuit, R and C are connected in series in the circuit. Resistance R is there, capacitor C is there. To charging a capacitor, there must be a resistance in the circuit. Otherwise, if there is no resistance, whenever you connect the battery to the EM of capacitor, automatically the capacitor is charged to the maximum value. If the EM of the battery is 5 volt, as soon as the current flows in the circuit, automatically the capacitor become 5 volt. If you connect 10 volts to the circuit, then as you switch on the circuit, suddenly the voltage across the capacitor about 10 volt. Means within short time, the capacitor is charged to the maximum value. That's why you have to use the resistance. You know already the definition of the resistance is the opposition to the flow of current. As there is opposition to the flow of current, then the charge stored in the capacitors takes some more time as the more resistance is used in the circuit. Okay? As the resistance is increased, the storage of charge in the capacitors takes a maximum time. If the resistance is lesser, storage of charge in the capacitors takes less time. Within a fraction of time, the capacitor charged to the maximum voltage. So, what voltage it can get, that is equivalent to the EM of our battery. Okay. Here the MOS key is there. See, upper terminal is connected to the MOS key, and this is the tap. When it is pressed, it is connected to the here. If it is connected to the lower part of the circuit, then EMF and RC are in the circuit like this. Okay? As EMF of battery is there in the circuit or present in the circuit, automatically current flows through the capacitor through the high resistance. As the current flows in the circuit, capacitors start to charge. The quantity of charge is flow in the capacitor. The quantity of charge flowing in the circuit depends upon the resistance value. Okay? Now, if it is released, automatically this upper part is connected to the MOS key here, and this part of the circuit is break off. As this is break down, only the resistance capacitors are made a short. No EMF of a circuit is there in the circuit. Means the EMF of the circuit is 0 when it is released. See this part. At that time, what initially capacitor stored during the charging means if it is pressed here, capacitor store the charge. If it is released, then capacitor start to discharge. High resistance. When there is no EMF of the circuit, EMF equal to 0, automatically capacitor is discharged, start to discharge. Okay. So this is the charging and discharging of the capacitor through high resistance. See, as per the circuit diagram here, R with the resistance, certain value of the resistance is considered here, C with the capacity of the capacitor. These two are connected in series and connected to the MOS key through a battery. When the key is pressed here, current start to flow in this part, okay, because this E is connected to the lower part of the circuit. Means the circuit is on. When the circuit is on, current flows in the circuit. Okay. Now, R and C are there in the circuit in presence of current. Automatically, capacitor start to charge. Okay. So, as a capacitor increases charge, voltage across capacitor gradually increased. Because as you know already, Q is directly proportional. Whenever increase the charge, voltage across the capacitor also increase. If the charge is minimum, voltage is minimum. When the charge is maximum, voltage also maximum. That's why the total EMF of battery in the circuit is always equal to PC plus PR. You know, the combination of resistance in the circuit as a two resistance or more than two resistance connected in series, and that combination connected to certain voltage across each resistance is different as the resistance are different. If you say R1, R2, R3 are the three resistors connected in series, certain voltage about 10 volt is given across the three resistors. Voltage across R1 is different, voltage across R2 is different, voltage across R3 is different because R1 and R2, R3 are different. If all the three resistors are same voltage is developed across the three resistors, but sum of the voltage across the three resistors is equal to the total voltage applied across the combination. In any connection of the series combination, either only the number of resistors in series, or number of inductances are in series, or number of capacitors are in series, or the combination of RLC like this. Whenever the components of the devices connected in series, voltage divides. Okay. So as there is a two elements here, one is a resistance, another is a capacitor. As these two are in series, then there is certain voltage across the R, there is certain voltage across the C when the charging key is pressed. When charging key is pressed, current will start to flow. Now, total EMF of battery is equal to what in this case? That is always Vc plus PR. That is Vc is a voltage across the capacitor, and here is the voltage across the resistance. Okay. Now, as per the equation, as you know already, three important equations. Voltage across the capacitor is considered as what? Q by C. And voltage across the resistance is what? That is I R. Okay. Ratio of the quantity of charge stored in the capacitor to the capacity of the capacitor is voltage across the capacitor. And product of the current and resistance is the voltage across the resistance. That is, equation shall be equal to Q by C plus IR. What is current? As per the definition of current, I equal to what? dQ by dt. How do you define current? That is rate of flow of charge. What quantity of charge flows in an interval of time? That is I equal to dQ by dt. As substitute I equal to dQ by dt in the above equation, that is E equal to Q by C plus I itself is considered as dQ by dt into R. Okay. Now, as the key is pressed after a long time, means after a certain time, voltage across the capacitor is increase. Up to what extent it can increase? Till the voltage of the battery, because what certain voltage of the battery is connected here. If it is 10 volt, maximum capacity of capacitor charge up to 10 volt. If you connect 5 volt battery for this, initially the current is switched on, the charge across voltage across capacitor increase by 0.5, 1, 1.5, 2.5, 3.5 up to 5. More than 5, it cannot store the charge because the given voltage is 5. Okay, if you connect 10 volt of 10 volt battery here, the capacity of capacitor can charge up to 10 volt like this. That's why as the current is switch on, current through the that is charge through the capacitor is increased and voltage across the capacitor go on increase. Then it reaches the EM of the battery, means voltage of the battery. That's why after long time means when the voltage of the capacitor is equal to the EM of battery, then the capacitor is saturated to store the charge. Then onwards, whatever you take the time, 5-10 seconds or 5 minutes, 10 minutes, 1 hour, like that, voltage will be constant. Up to what extent capacitor can be increased the charge till the voltage across the capacitor become equal to the EM of a battery. That's why E equal to what? Q naught by C here. Or E equal to V naught. V naught itself is a maximum voltage across the capacitor, that is equal to Q naught by C. Okay. If substitute the value of E equal to V naught or Q naught by C in the above equation, what? E itself is what? Q naught by C equal to Q by C plus I is substituted as dQ by dt into R. Okay, this is a equation. E equal to Q by C plus IR can be written as E is equal to the maximum voltage after certain time. After certain time means when the voltage of the capacitor is the maximum. That is equal to Q naught by C. So E is substituted as Q naught by C equal to Vc itself is Q by C plus IR. I is nothing but the flow of charge in a period of time, dQ by dt now into R. This above equation is Q by C, Q naught by C minus this take this side, Q by C is equal to dQ by dt into R. Or this you can write Q naught minus Q, because a denominator term is same, that you should take it as a C value. Q naught minus Q by C is equal to dQ by dt into R. Or this takes this side, dQ divided by this takes this side, that is Q naught minus Q is equal to C takes this side and make the dt comes under this side, dt divided by RC. Is it understand? That is Q naught minus Q by C is equal to dQ by dt R. So dt takes this side, R in the denominator, dt by RC. Okay. Q naught minus Q takes this side, that is dQ by Q naught minus Q. Now integrate this equation. Integrate this equation. Integrate equation on both sides. What is the integration of dQ by Q minus Q naught? That is log of minus log of Q naught minus Q. Okay, that is the integration of dx by x. Integration of dx by x is a log x. Okay, or integration of dx divided by a minus x. Dx by a minus a is a constant, so that it is a log of a minus x. As a minus x is there, you take the minus sign here, so that as there is a minus of q, q is a variable, q naught as such constant, because q naught is the maximum charge. Therefore, the equation you can write now after taking the integration of this term. minus log q naught minus q is equal to integration of dt is a t by RC as constant. Okay, R is a constant, C is a constant because the value of the capacitor and resistance will not change in the circuit. Plus integration constant T. Okay. Now, if T is equal to 0, what is the meaning of T equal to 0? If the current is switched off for a certain time, then only capacity of the capacitor is charged to the certain value. T equal to 0 means before the current is switched on, the charging interval is 0. As there is no charging interval, voltage across the capacitor becomes 0, charge of the capacitor is 0. So that T equal to 0, Q is equal to 0. Okay. Before the current is switched on, there is no capacitor, charge in the capacitor. That's why when T equal to 0, Q equal to 1. Okay. So substitute all these values in the above equation. Minus of log Q naught minus Q, Q becomes 0, minus log Q naught, Q becomes 0, equal to T becomes 0, 0 by something is 0, so that it gives a value of K, integration constant. Now, substitute this value of K in the above equation. That is, above equation becomes what? Minus log of Q naught minus Q is equal to T bar RC plus K, nothing but K value is minus of log Q naught to the base E. Log to the base E is considered always. Okay. Now, or this you can write like this: log of Q naught minus Q to the base E, minus it become plus when it takes at the left side. That is log of Q naught to the base E is equal to T divided by RC. Okay. Now, multiply by negative sign to this equation. Minus of minus plus. So that log of Q naught minus Q to the base E plus become minus. When you are multiplying minus here, plus into minus is minus. Log of Q naught to the base E is equal to, that is minus T by RC, because you are multiplying this minus sign on both sides of the equation. Now, the equation becomes what? Here, log of A minus log of B is log of A by B. Like that, that is log of Q naught minus Q divided by Q naught to the base E is equal to minus T by RC. If you remove the log at the left side, you should take the exponential term at the right side of it. That's why Q naught minus Q divided by Q naught is equal to e raised to minus T divided by RC. Q naught minus Q divided by Q naught equal to e raised to minus T by RC. Or that is Q naught by Q naught is 1 minus Q by Q naught is equal to e raised to minus T by RC. Or you can write that minus of Q by Q naught takes this side and this term takes this side. That is Q by Q naught is equal to 1 minus e raised to minus T by RC. Or you can write this equation: Q is equal to Q naught into bracket 1 minus of e raised to minus T by RC. This is the expression, final expression for charging of capacitor after any time. If capacitor is charged to the maximum value by taking the time t. Okay. In between 0 voltage to the maximum voltage, it takes certain time, say about 20 seconds. In the interval between 0 to 20 seconds, if you want to charge on the capacitor at any interval, if after 5 seconds, what is the charge of the capacitor? One may ask question, what is the charge on the capacitor after 7 seconds, 15 seconds, 18 seconds? Not more than 20, because the charging process takes place up to 20 seconds. If the 20 seconds is maximum time, within that the capacitor is charged to the maximum. So, charge at any instant of time, we can find it Q equal to Q naught 1 minus T raised to minus T bar C. T with the charging interval, R with the resistance used in the circuit, C with the capacity of the capacitor. So, this is the expression for the charge of the capacitor at any interval of time during charging of the capacitor through high resistance R. If you divide by C on both sides of this equation, that is Q by C is equal to Q naught by C into bracket 1 minus e raised to minus T bar RC. Q by C itself is a V. V is equal to Q naught by C itself, consider V naught, into bracket 1 minus e raised to minus T by RC. So this is the expression for voltage across the capacitor at any instant of time. V is the voltage for a time t when R and C are present in the circuit. That V naught is the maximum voltage across the capacitor. That depends upon the EMF where battery connected to the circuit. So this is the expression for charging of a capacitor. Okay. And in the next class, we shall discuss about the time constant of circuit and the discharge of the capacitor. Thank you. ये दूसरे पूछे ला ऑनलाइन